Hello everyone. Today I'm going to show you how to use StatCrunch to do the test of independence for the contingency table. This question first is number 7 in the homework 11. So the table below indicates results from polygraph experiments, and it was known if the subject lied or did not lie. So the table indicates whether the polygraph test was correct. Use 0.05 significance level, so alpha equal to 0.05, to test the claim that whether a subject was lying or not is independent of the polygraph test, and some other things. So first you want to open this in StatCrunch. So you can see the table. The columns are the people lie, do not lie, or lie. So, and for the row will be the polygraph result. So the polygraph indicate someone is lying or not. So those are the frequencies for each of those combination here. So we want to test whether the row variable and the column variable, they are independent or not. So what you do is go to Stat, Tables. It's a contingency table, and it's a summary. It's not a long column of data. It's just a summary of the data with the frequencies. So first, you need to select the column with a frequency in it. So you keep pressing Shift and click both of them. Did not lie and lie. Those are the two columns with a frequency in it. One thing about this is you have to choose the row labels, which is the first column. If you move this, you can see that, the first column here, this underline will be the row name, or say row label. So you have to choose that as your first column, as your row label. Okay, and then you want to display the expected counts. If you want to check whether the expected counts are bigger or equal to 5, then you click compute. So here, upper here, you will have a table, but for each cell here, you will have two numbers. Upper here shows the number of the observed frequency, and down here in the bracket, this shows you the expected frequency if the row and column are independent. You can see them all bigger or equal to 5. So that's good. That means this test is valid. So here, down here, it shows that the test statistic is using is chi-squared with a value of 14 point something, and the p-value is showing here. Okay, so those things you need to do, you need to that for the answering the question. So if you go back, first it's asking the null and alternative hypothesis. Now is whether subject lies independent of the polygraph tested indicator. So column independent of the row. And for the alternative hypothesis, it's not independent. And down here, for the chi-square, test the statistic value. It should be here. So it is this value here. That's a chi-square equal to this 14.118. And the p-value, you copy this p-value, which is the last column here. So those are those two numbers. And then do this results suggest that the polygraph is effective in distinguishing between the truth and lies? So from the p-value, if you compare that with your alpha, which is 0.05, you know that p-value is really small. That means you need to reject the null hypothesis. So you need to reject that the two variables are independent. And that's why you need to choose C. There is sufficient evidence to warrant the rejection of the claim that this is H naught. Okay. So that's number 7. Number 8. It's also very similar example. The results from a civil servant exam are shown in the table on the right. So is there sufficient evidence to support the claim that the results from the test are discriminatory? So it has white candidate and minority candidate. So what they want to say is, say the ratio of the frequency of pass and the failed, are they remain the same for the white and for the minority? If it remain the same, in other words, the row data, row variable and the column variable are independent, that means no discrimination. Okay, still the independent test. So H0, the white and minority have the same chance of passing the test. In other words, row variable and column variable are independent. And H1, they do not have the same chance of passing the test. And again, in order to get the chi-square and the p-value, you need to go to StatCrunch. And then you go to Stat, Tables, its contingency, and the summary. First, you need to select the columns with the frequency. Again, you keep pressing the shift and you click both the passed and the fails. Those are the two columns I believe the frequencies are. And the row label, again, is the first column. It's the underline. Display expected and compute. And down here, you will have the chi-square equal to 6.938, which is this value, and the p-value here. Okay, and those are the next two things you need to fill in here. You copy those numbers here. And because this p-value is really small, it's smaller than the alpha used, 0.05, so there is sufficient evidence to support the claim that the results are discriminatory. In other words, you reject the null hypothesis.